Hello, so this video is about section 2.1, representing relations and functions. The essential question is, how do you graph relations and functions? Our objective is to represent relations and graph linear functions. All right, so we have a key concept. A relation is a mapping or a pairing of input values with output values. So we should actually change this word to of. Okay. The set of input values is called the domain, and the set of output values is called the range. Okay. So what we're talking about here is a relation just puts two numbers together. So the number 1, 2, okay, and this is represented as an ordered pair. And you've seen these before, so often it's the x comma the y. So a relationship just says the number 1 goes with the number 2, okay? It maps, okay? Another way we can write that is we have a set of input values and we have a set of output values, okay? And we usually let sets be represented by nice ovals. So in this example, we have the input value 1 and we have the output value 2. And the mapping says take 1 and map it to 2, okay? The inputs are the x values. The outputs are the y values, okay? And they're also known as inputs are domain and outputs are the range. Okay. So in example 1, let's consider the relation given by the following points: 3, 2, -1, 0, 2, -1, -2, 1, and 0, 3. We want to identify the domain and the range. So the domain, those are the set of numbers that consists of all the first coordinates in our ordered pairs. And what we do is we write that in a curly brace, and we simply write all of the x values. So using my highlighter, I'm going to use orange. I'm going to highlight all of my x values. Okay, so there's my domain. Now when I write the domain, we usually write them in increasing order. So I'm going to start with -2 because that's my smallest number. Then I go to -1. And then I have 0, and then I have 2, and then I have 3. And then I end that by another curly brace. Now for the range, that's going to be all of my y coordinates or my second coordinates. So I'll use another color. So all of these here are going to be my range. Okay, and again, we're going to write that with the smallest number first in curly braces. So we put -1, 0, 1, 2, and 3. Now, to represent this relation using a graph and a mapping diagram. So for the graph, it's just a coordinate axis. So here's your x and here's your y. And I'm just going to give these some numbers: 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So my first point, 3, 2, go to 3 on the x and 2 on the y, and I plot the point. -1, 0, I plot the point. 2, -1, I plot the point. -2, 1, I plot the point. And 0, 3. Now this is the relation. I just graphed all of the points. Another way we can do that is by doing the input and output graph, and that's also referred to as the mapping diagram. So I have my two ovals, one for my inputs and one for my outputs. And then my inputs, I put my domain values: -2, -1, 0, 2, and 3. And then my outputs, I put my range: -1, 0, 1, 2, and 3. Now the first point is 3, 2. So that says 3 goes to 2. -1 goes to 0 is my next point. 2 goes to -1, that's my next point. And then -2 goes to 1, that's this point. And then 0 goes to 3. And I have now done a mapping diagram. Now, a special type of relation is a function. So a function is a special relation in which every input has exactly one output. If there are any input or relations that has more than one output, the relation is not a function. So let's do a couple examples. So here is a function, and let's just do -2, -1, 0, and 1. So to be a function, and then make some points up here: 3, 6, 9, 12, 13, 14. Okay. Every input has exactly one output. So -2 only goes to 3. -1 only goes to 6. 0 only goes to 9. And then 1 only goes to 12. Each of these inputs have one arrow going out. Okay. Now, let's take a look at not a function. Okay, so again, I have a set of input values and a set of output values. So now let's go -2, -1, 0, 1, and 2. And let's go to 4, 5, and 6. So -2 goes to 4 and -2 goes to 5. -1 goes to 5, 0 goes to 6, 1 goes to 5, and 2 goes to 4. Now the reason this is not a function is -2 has two outputs. It doesn't matter how many arrows go to a number. So here we have 2 places going to 4. That's okay. What's not okay is the input going to 2 different places. That's what makes it not a function. So let's try example 2. Is the relation a function? So here is my inputs and here are my outputs. Now notice 3 goes to 2 different places, -1 and 2. This input has 2 outputs. So by definition, this is not a function. So the input 3 is mapped onto both -1 and -2. All right, this next example, -3 has 1 spot, 0, 1 spot, 2, 1 spot, 6, 1 spot. That's good. It's okay that 5 has 2 arrows. That's okay. So this is yes. Okay, each input is mapped onto exactly one output. Right. So why don't you try guided practices 1 for parts A and B. Okay, and then you're going to try guided practice number 2. All right, I'll give you a minute to try those. All right, welcome back. So in A, you should have written the domain as the set consisting of -4, -2, 0, and 1. And then the range is going to be the set consisting of -4, -2, 1, and 3. All right, part B represents using a table and a mapping diagram. So the table, we have x's and y's. So I just write down my points. The first point is -4, 3. Then I have -2, 1. Then I have 0, 3. And then I have 1, -2. And then I have -2 and -4. The mapping diagram, I have inputs and I have outputs. So I'm going to draw this oval, I'm going to draw this oval, and I write my values of my inputs, -2, -4, -2, 0, and 1. And my outputs are -4, -2, 1, and 3. So my first point, -4 goes to 3. I draw that arrow. -2 goes to 1. I draw that arrow. 0 goes to 3. I draw that arrow. And then 1 goes to -2. And then -2 goes to 4. Okay. All right, number 2, guided practice number 2. So what you should have done there is said, yes, this is a relation, is a function, because each input has exactly one output. Okay. Now, another way we could determine if a relation is a function is by doing something called the vertical line test. So what that says is, if I have a graph of a relation, if I draw a vertical line anywhere on that graph, it can only touch once. Okay. So here is an example. Let's look at a relation that looks something like this. So here's a point, here's a point, here's a point, here's a point, and here's a point. If I drew a vertical line anywhere, okay, it only can touch once. Now watch this. This vertical line touches twice. So that means this is not a function. It fails the vertical line test. Okay. Same thing with the graph. So we might have a function that looks something like this. Okay. If I draw a vertical line anywhere, notice it only touches once. So this is, yes, a function. Okay. So another key concept. Many functions can actually be described as an equation in two variables, such as the equation y equals 3x minus 5. The input variable will be x, which is called an independent variable. The output variable y will be called the dependent variable because it depends on what the input value is. So for example, let's graph the equation y equals 3x minus 5. So what we're going to start off doing is by making a table of values. We have x's and y's. What we do is we pick values for our independent variable x. Okay? We can pick any x's we want. I might pick -2, -1, 0, 1, and 2. Now, I don't know what my y values are because each y value depends on what my x value is. So what I do is I substitute in. So my first value, I have 3 times -2 minus 5, and that equals -11. So that's the point that goes here. My next one, I have 3 times -1 minus 5, and that equals -8. And that's the point that goes there. My next one is 3 times 0 minus 5, and that's going to give me -5, and that's the point that goes there. Then I have 3 times 1 minus 5, and that's going to give me -2. And then I have 3 times 2 minus 5 equals 1. And now I go plot it. Now we have a slight problem in that my axes only go out to 5. So these two are just bigger than the graph. That's okay. So I'm actually going to start graphing here. So I have 0, -5, I plot the point. 1, -2, I plot the point. And 2, 1, I plot the point. 3 points are the minimum that we need, and I just connect the dots and draw the line. And there you go. So key concept, the function in example 3, y equals 3x minus 5, is a linear function because it can be written in the form of mx plus b. M represents the slope, and b represents the y-intercept. Okay. Another reason it's called a linear function, okay, linear, is because the variable x only has a power of 1. So x is to the power of 1, which means it's linear. Okay. 2 ways we can write this. We can write this in xy notation, y equals mx plus b, or we can change y and make it f of x, and this is called function notation. So 2 different notations. So y is the same as f of x. All right, so example 4, tell whether the function is linear and then evaluate the function. In A, do you see how the power of x is 3? It's not 1, so this means it's not linear. Now I'm going to evaluate f -3. So f of -3 equals -2 times -3 cubed plus 5. So notice I just substitute in -3 wherever I see an x. That's what this notation means. What the number inside the parentheses means I just substituted in everywhere I see an x. So simplifying this, we get -2 times -27 plus 5. So this is going to give me -52, positive 52, excuse me, plus 5, or 54. Positive 54 plus 5, and that gives me 59. So the answer, f of -3 equals 59. All right, B, x only has a power of 1, so that means it's a linear function. And now I'm going to evaluate g of -3. So that means wherever I see an x in my original function, I substitute in -3. So I have 12 plus 24, and that's how I get 36. And that is the value of g of 3. Okay. So for guided practices, why don't you try to graph the equation y equals 3x minus 2. All right, let's check our answers. So we have x, y. I'm going to plug in -2, -1, 0, 1, and 2. So my first point, I have 3 times -2 minus 2, and that's going to give me -8. My next point, I have 3 times -1 minus 2, and that's going to give me -5. My next point, I have 3 times 0 minus 5, and that's going to give me, minus 2. And that's going to give me -2. And then I have 3 times 1 minus 2, and that's going to give me 1. And then I have 3 times 2 minus 2, and that's going to give me 4. Again, I'm only going to plot the points that fit on my graph. So I have -1, -5. I have 0, -2, 1, 1, and 2, 4. And then I draw a line to go through all my dots, and there is your graph. All right, now try guided practice 5 and 6. All right, so in number 5, you notice you have an exponent of 3, so this right off the bat makes this not linear. So then we want f of -2. That means anywhere you see an x, you're going to substitute in a -2. Remember to use parentheses. So this is going to give me -3 minus -8, which is going to give me +5. So f of -2 equals 5. All right, number 6. There's only a power of 1, so this is a linear function. So then g of -2 equals -4 times, minus 2 times -2. So that equals -4 plus 4, so that equals 0. So g of -2 equals 0. All right, let's try example 5. This is kind of a word problem. The length L in inches that a spring stretches up to a weight, when a weight up to 20 pounds is attached to it is given by the equation L of W equals 1/12W plus 2, where W is the weight in pounds. So we're going to graph the function and then determine a reasonable domain and range. What is the length of the spring when a 10-pound weight is attached? Okay, so what I like to do first actually is identify my domain, which are my possible x values. So this is in real life. So my domain, if you notice, is my w's. So what values can my w's go between? So this spring can only hold weights up to 20 pounds. That's my maximum. That's the number that goes over there. Now let's think about a weight. Can weights be negative? No. The smallest weight I can put on is nothing, which is going to be 0. Now, the next thing I find is going to be my range. Now, since this is a linear function, one way we can find the range is just by substituting in the endpoints of my domain. So I'm going to find L of 0 first, and that's going to be 1/12 times 0 plus 2. And that gives me 2. So that's my lowest value. Then I'm going to substitute in L of 20, and that's going to equal 1/12 times 20 plus 2, which equals 3 2/3. So that's my highest value, and that's my range. Now, in the problem, it also asked me to evaluate for 10 pounds, so I might as well do that. All right, so I have 1/12 times 10 plus 2, and that's going to give me 2 5/6. Now, what I just did there was I found 3 points. So this first point is 0, 2. This next point is 20, 3 2/3. And my last point was 10, 2 5/6. I'm going to use those to graph. So here's 0, 2. Here is 10 2 5/6. About there. And then here's 20 3 2/3. Right about there. And I draw a line that goes through them, and I have graphed this function. And that is the end of this section. Now, if you notice, your homework assignment might be different. I believe I forgot to update this. So check high Q for the actual assignment.